Hello, welcome to One Baha'i. Whoa, sorry. As soon as the video started, the sun just came out. Wow. Hi, welcome to One Baha'i, that regular show where I just get blinded by the light. Holy mackerel. My eyes really weren't used to the sunlight all of a sudden. So, welcome to One Baha'i, that regular show where I just sit back and share a few personal thoughts about the Baha'i faith. As you know, it's nothing official, it's just me, one individual, one Baha'i. So I wrote a bit of an introduction this morning, because, I wanted to recap. So just to start, I'm a layperson. While I studied some physics at university, it is not my profession. I'm a fashion designer and jeweler. But the perspective I'm offering is that of a layperson. While I did run this by a professor of physics, and he said that my understanding was sound, I'll probably still get a few things wrong in this video, so I do apologize. The mistakes are all mine. In part one, we mentioned nature as the great metaphor for spiritual truths. We also looked at how we tend to see the latest technology as another metaphor. God is the clockwork, the brain is a computer. Today, I want to talk a little bit about black holes and Stephen Hawking, and show a little bit about what we can learn from black holes as a metaphor. And no, it's not because they suck, okay? So, we detect black holes through X-ray radiation. We can detect the X-ray bursts with our telescopes. The question is, how do those X-rays get produced? One of the older theories was that when an atom is close enough to the center of a black hole, close enough to a black hole, the atom gets crushed. And as we know from nuclear fission and nuclear fusion, when an atom is broken, it releases a tremendous burst of energy. When the atom is that close to a black hole, the theory is that the crushing of it releases energy, the matter in the atom gets sucked into the black hole, and so does most of the energy. But the X-rays are of a high enough energy that they get to zip out, they escape the gravitational pull, which is why we can detect them. That was the theory. Stephen Hawking, probably 40 years ago, I'm not sure on the timeline, he postulated a second idea. He said, what if black holes evaporate, and the vapor that they give off is X-rays? Now, from what I understand, there are all sorts of mathematical formula that can predict this and talk about it and show it. That's totally beyond me. But let's go back a moment. Because, some of the things that we know from physics, astrophysics in particular, first, nothing escapes the gravitational pull of a black hole. Okay, fine, no problem. We also know that time flows in relation to a gravitational pull. The stronger the gravity, the faster the time, subjectively. That's actually intuitively backwards. If you have two twins, you send one into outer space. When he comes back, he will be much younger than the one on Earth. The Earth-bound twin will have aged faster. Okay, given this, the theory is that the idea is that if we could stand on a black hole, time would move in such a manner that we would see the entire universe all at once. From start to finish. Time would move so quickly around us that we would see the entire universe from its birth to its death. Now, another aspect of astrophysics is that it tells us that the universe is expanding. Which is why we have the Big Bang Theory. Everything started in a single point, boom, and it's moving outwards. And because we could detect that things were moving away from us, we could just rewind and figure out when that explosion happened. 13.6 some billion years ago. The problem, though, is that when we detect the movement of things away from us, we actually notice that they are moving faster and faster. The more time elapses, the faster things are moving away from us. Now, this is contrary to all expectation. You see, if in a normal explosion, everything starts to explode and it gets slower and slower, and the explosion dies out. With the creation of the universe, we understand that things started exploding and then they're moving faster and faster and faster. And if you think about it over time, what it means is what they call the cold death of the universe. Everything will be so far apart that all energy, all matter will have dissipated and we will be left with a cold void. Now, this doesn't really make a lot of sense to me. I mean, sure, the maths work out, but there's got to be something beyond this. Now, when we talk about the beginning of the universe, it's a very strange phrase because the initial universe in a point would have been so dense, like a black hole, that all time would have warped around it. So when we say it's the beginning of the universe, it's also the beginning of measurable time. So when we ask what happened before the Big Bang, it's not really a question that has any meaning because time itself stops at the moment of Big Bang. So the question becomes meaningless. And the idea of time beginning at the Big Bang also vindicates the religious concept found in many religions where it talks about the beginning that hath no beginning. And I like that because now we're beginning to see that the science is beginning to make sense of the religion. They do appear to be coming closer and closer to each other. Okay, now let's go back to Hawking. What if black holes evaporate? You see, earlier I said that things are moving faster and faster apart, and things are also coalescing into black holes. So when I say that there would be nothing left, well, what there would be a series of black holes all over the place where matter condensed into them. Okay, fine, no problem. Hawking postulated that when a black hole evaporates enough, I don't know what that means, but it sounds good. When it evaporates enough, it will explode. So here you have a black hole slowly vaporing off its X-rays. Boom. I like to picture it as a bubble of time and universe. A bubble universe. Time itself begins within that exploding sphere. And again, like I said, this is just a layperson explaining it, but the physicists I know have said that I've got the basic concept of what they're talking about. So now we can imagine the entire universe, 13.6 some billion years ago, being a black hole, space and time warped around it in such a manner that it's a single point with no time happening. It explodes, the matter is ripped apart, time itself begins to have a concept and begins flowing, and we can see it as a giant bubble. But of course, there's probably more than one. And this is what Hawking predicted. He said that if it explodes, then there was probably another one over here, and another one over here, and another one here, and there, and there, and they're probably happening all over the place. And the way that we could detect it is that these explosions, one here, would start to come closer and they would overlap. And we would be able to detect an increase in temperature at the edges of the universe, presumably in growing circles where they overlap. Last, I think it was September, we actually noticed this. Physicists detected an increase in temperature at the edges of the universe, as Hawking predicted. This has phenomenal implications on the spiritual concepts of religion. I want to leave you with that today. It was enough to just explain the science of it. Tomorrow, I want to talk about the spiritual implications of that. Thank you for joining. You know the usual, hit like and so on and so forth. And, well, stay safe. Hope you're doing well. Take care.